Arc fault circuit interrupter, or AFCI, devices have significantly changed residential electrical wiring practices. Firstly, there's the impact on the number of devices on a circuit. AFCI devices are designed to trip on small transient arcs that conventional circuit breakers might have ignored. To mitigate nuisance tripping, electricians often split circuits into smaller segments with fewer devices. This enables them to install more outlets and lighting fixtures on a single circuit without the risk of the AFCI tripping unnecessarily. Secondly, electricians now staple wires much more gently. AFCI devices are highly sensitive and can detect loose connections in wires. Overstapling or pinching wires can create tiny gaps, which can cause electrical arcing and trigger the AFCI. Electricians now use specific tools designed to avoid damaging the insulation when stapling wires. They also use wire staples with rounded edges to prevent sharp points from piercing the insulation, which is important to prevent future problems. Beyond those two examples, there are additional changes that have occurred since the adoption of AFCIs in residential electrical wiring. One major change is the increased use of non-metallic sheathed cable, or NMB. AFCI devices are generally more compatible with NMB cable than with metal-clad cables. This is due to the reduced electromagnetic interference associated with NMB cable, which can sometimes cause false tripping in AFCI devices. Another critical area of focus is careful wire termination. Electricians now emphasize clean and solid wire terminations to prevent loose connections. Loose connections are a common cause of electrical arcing and can easily trigger nuisance tripping in AFCI devices. Ensuring tight and secure connections at all points in the electrical system is crucial for reliable AFCI operation. In addition to the above, arc fault evaluation tests may be performed during the installation process. Electricians may conduct these tests to identify potential problem areas that could lead to arc faults. This proactive approach helps to ensure that the electrical system is functioning correctly and that AFCI devices will not be prone to nuisance tripping. Proper grounding is another essential aspect of AFCI operation. A secure ground connection is crucial for proper AFCI performance. Electricians now pay extra attention to ensuring reliable grounding throughout the electrical system, as a poor ground connection can interfere with the AFCI's ability to detect arc faults. It is also important to consider the challenges that have arisen with the increased use of AFCI protection. One challenge is increased labor time. Splitting circuits into smaller segments and stapling wires more gently both add time to the installation process. Electricians need to factor in this additional time when estimating project costs. Another challenge is compatibility issues. Electricians need to be aware of compatibility issues between AFCI devices and certain types of loads. Some loads, such as fluorescent lighting or motor-driven appliances, can generate electrical noise that can cause AFCI devices to trip. It's important to select AFCI devices that are compatible with the specific loads being used in the home. Finally, even with careful installation, nuisance tripping can still occur in certain situations. For example, devices being turned on or off in rapid succession can sometimes trigger an AFCI. While nuisance tripping can be frustrating for homeowners, it is important to remember that the AFCI is doing its job by detecting potential arc faults. Several factors contribute to the way residential electricians address AFCI requirements in their wiring practices. The increased sensitivity of AFCI breakers necessitates more careful circuit design and installation techniques. Electricians often design circuits with fewer devices to minimize the risk of nuisance tripping. This might involve splitting up lighting and receptacle loads onto separate circuits to reduce the overall current and potential for arc faults. When installing wiring, electricians pay close attention to avoiding any damage to the insulation. Nicks or cuts in the insulation can create a path for current leakage and lead to arc faults. As such, they use specialized tools and techniques to ensure that the wiring is properly supported and protected. Grounding is another area that receives extra attention. AFCI breakers rely on a solid ground connection to detect arc faults. The electricians take extra care to ensure that all grounding connections are tight and secure. They also verify that the grounding system is properly sized and installed according to the applicable electrical codes. Wire terminations are also meticulously executed. Electricians use proper techniques to strip and terminate wires, ensuring that connections are tight and corrosion-free. Loose or corroded connections can create resistance and heat, which can lead to arc faults. They also follow the manufacturer's instructions for installing AFCI breakers, ensuring that they are properly connected to the electrical panel and that all connections are tight. Once the wiring is complete, electricians often perform testing to verify that the AFCI breakers are functioning correctly. This might involve using a specialized AFCI tester to simulate arc faults and confirm that the breaker trips as expected. Electricians stay up to date on the latest AFCI technology and installation techniques. They attend training courses and read industry publications to ensure that they are knowledgeable about the latest requirements and best practices. Electricians are also aware of the limitations of AFCI breakers and are careful not to overload circuits or install them in areas where they might be prone to nuisance tripping. They also communicate effectively with homeowners, explaining the purpose of AFCI breakers and how they work. This helps to ensure that homeowners understand the importance of not tampering with or bypassing these safety devices. In summary, the requirement for AFCI breakers has significantly changed the way residential electricians wire houses. By paying close attention to circuit design, wire installation, grounding, and wire terminations, electricians can ensure that AFCI breakers function correctly and protect homes from electrical fires. One might ask, what are some specific examples of how electricians are wiring houses differently to accommodate AFCI requirements? Well, here are a few examples. Firstly, circuit layouts are being planned carefully. Electricians are now more strategic in how they lay out circuits to minimize the number of devices on each one. This helps to reduce the overall current flow and the potential for arc faults. Secondly, wire routing is done carefully. Electricians take extra care to route wires in a way that minimizes the risk of damage or stress in the insulation. This might involve avoiding sharp bends or tight spaces. Thirdly, cable protection is taken seriously. Electricians use cable clamps and staples to properly support and protect wiring. This helps to prevent damage from physical stress or vibration. Fourthly, junction box wiring is neater. Electricians take extra care to make neat and organized connections in junction boxes. This helps to prevent loose connections or cross wires. Fifthly, receptacle installation is performed carefully. Electricians use proper techniques to install receptacles, ensuring that they are securely mounted and properly grounded. Sixthly, lighting fixture installation is performed carefully. Electricians use proper techniques to install lighting fixtures, ensuring that they are securely mounted and properly wired. Seventhly, panel board wiring is precise. Electricians take extra care to make neat and organized connections in the panel board. This helps to ensure that the electrical system is functioning correctly and that AFCI breakers will not be prone to nuisance tripping. Eighthly, final inspections are more comprehensive. Electricians perform thorough final inspections to verify that all wiring is installed correctly and that AFCI breakers are functioning as expected. Finally, homeowner education is emphasized. Electricians take the time to educate homeowners about the purpose of AFCI breakers and how they work. This helps to ensure that homeowners understand the importance of not tampering with or bypassing these safety devices. The changes in wiring practices also include a greater emphasis on wire management within electrical panels and junction boxes. Electricians are now more meticulous in how they arrange and secure wires to prevent them from becoming tangled or damaged. They use cable ties and other organizational tools to keep wires neatly bundled and out of the way. Proper wire management not only improves the appearance of the electrical system, but also makes it easier to troubleshoot and maintain. Another significant change is the increased use of torque screwdrivers when making electrical connections. Electricians now use torque screwdrivers to ensure that all connections are tightened to the manufacturer's specifications. This helps to prevent loose connections, which are a common cause of arc faults. By using torque screwdrivers, electricians can ensure that connections are consistently tight and reliable. Electricians are also more careful when selecting and installing electrical boxes. They choose boxes that are appropriately sized for the number of wires and devices being installed. They also ensure that the boxes are securely mounted and properly grounded. Proper box installation is essential for preventing damage to wiring and ensuring the safety of the electrical system. Additionally, electricians are now more likely to use wire markers and labels to identify circuits and wiring. This makes it easier to troubleshoot and maintain the electrical system in the future. Wire markers and labels help to prevent confusion and ensure that the correct circuits are being worked on. Electricians are also more aware of the potential for electromagnetic interference, or ME, to affect AFCI performance. They take steps to minimize EMI by routing wiring away from sources of interference and by using shielded cables when necessary. Minimizing EMI helps to prevent nuisance tripping and ensures that AFCI breakers are functioning correctly. Electricians are also more likely to use surge protectors to protect sensitive electronic equipment from voltage spikes. Surge protectors help to prevent damage to electronic devices and can also reduce the risk of arc faults. Surge protection is an important part of a comprehensive electrical safety plan. Electricians are also more likely to recommend that homeowners install whole-house surge protection. Whole-house surge protection provides protection for all of the electrical circuits in the home and can help to prevent damage to appliances and electronic devices. Whole-house surge protection is an effective way to protect against power surges caused by lightning strikes or other electrical events. Electricians are also more likely to recommend that homeowners have their electrical systems inspected regularly. Regular electrical inspections can help to identify potential problems before they become serious. Electrical inspections can also help to ensure that the electrical system is up to code and that it is functioning safely. Electricians are also more likely to use thermal imaging cameras to inspect electrical systems. Thermal imaging cameras can detect hot spots in electrical wiring, which can be a sign of a potential arc fault. Thermal imaging is a non-invasive way to identify electrical problems and prevent fires. Electricians are also more likely to use ground fault circuit interrupters, or GFCIs, in wet locations. GFCIs are designed to protect people from electric shock by detecting ground faults and interrupting the circuit. GFCIs are required in bathrooms, kitchens, and other wet locations. The National Electrical Code, or NEC, Article 210.8 provides the requirements for ground fault circuit interrupter protection for personnel. According to the NEC, GFCIs are required in dwelling units in bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and laundry areas. This regulation ensures safety in areas where water and electricity may come into contact. Electricians are also more likely to use arc fault circuit interrupters, or AFCIs, in bedrooms and other living areas. AFCIs are designed to protect against electrical fires by detecting arc faults and interrupting the circuit. AFCIs are required in bedrooms, living rooms, and other living areas. The NEC Article 210.12 provides the requirements for arc fault circuit interrupter protection. According to the NEC, AFCIs are required in dwelling units and all branch circuits that supply 120-volt single-phase, 15-amp and 20-amp outlets installed in dwelling units in kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, and similar rooms or areas. This regulation provides fire safety in homes. Electricians also need to consider the type of wiring being used. They are aware that AFCI devices are more compatible with non-metallic sheath cable, or NMB, than with metal-clad cables due to reduced electromagnetic interference. Careful termination is another critical aspect. Wire terminations must be clean and solid to prevent loose connections that could trigger nuisance tripping. Electricians may perform arc fault evaluation tests during the installation process to identify potential problem areas. Proper grounding is essential for proper AFCI operation, so electricians pay extra attention to ensuring reliable grounding throughout the system. Electricians also face challenges such as increased labor time, as splitting circuits and stapling wires more gently can add time to the installation process. They also need to be aware of compatibility issues between AFCI devices and certain types of loads, such as fluorescent lighting or motor-driven appliances. Nuisance tripping can still occur despite careful installation, such as when devices are turned on or off in rapid succession. The use of AFCI devices has also led to a greater emphasis on proper labeling of circuits. Electricians now take extra care to label each circuit clearly and accurately so that homeowners can easily identify which circuit controls which outlets in appliances. This is important for troubleshooting and maintenance purposes. In addition, electricians are more likely to use circuit directories to document the layout of electrical circuits. Circuit directories provide a comprehensive overview of the electrical system and can be helpful for future repairs or renovations. Electricians are also more likely to use surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can help to prevent damage to computers, televisions, and other electronic devices that are susceptible to power surges. Furthermore, electricians are more likely to recommend that homeowners install a backup generator. A backup generator can provide power during a power outage and can help to prevent damage to appliances and electronic devices. Electricians also need to be familiar with the latest electrical codes and regulations. The National Electrical Code, or NEC, is updated every 3 years, and electricians need to stay up to date on the latest changes. The NEC provides guidelines for the safe installation of electrical systems and is essential for preventing electrical fires and other hazards. Finally, electricians play an important role in educating homeowners about electrical safety. Electricians can provide homeowners with information about how to prevent electrical fires, how to use electrical appliances safely, and how to respond to electrical emergencies. Educating homeowners about electrical safety is an important way to prevent accidents and save lives. Electricians are also trained to recognize and address potential hazards in existing electrical systems. This may involve identifying outdated wiring, damaged outlets, or other safety issues that need to be addressed. Electricians can then recommend repairs or upgrades to improve the safety of the electrical system. In summary, the requirement for AFCI breakers has had a significant impact on residential electrical wiring practices. Electricians are now more careful in their circuit design, wire installation, grounding, and wire terminations. They are also more likely to use surge protection devices, backup generators, and other safety equipment. By following these best practices, electricians can help to ensure the safety of homes and prevent electrical fires.